In this recording, we are in section 6.6, which is still called the equation of a line. What is 6.1 called? Oh, it's also equation of a line. Look at that. So we're still on the equation of a line. We are going to continue with this topic for a bit, just so that we can really get comfortable with it. This is an important topic because it will be used, the equation of a line will be used in math courses from now through all the rest of your high school. So you need to know it. We never really reteach it from the beginning again, so it's really important to get this topic understood and be able to be comfortable with it. So this one says, given the information below, write the equation of a line in slope y-intercept form. So slope y-intercept form, sometimes we describe it in words. This is in the y equals mx plus b form. That's what it's asking for. We always fill in the m and fill in the b, and we leave y and x alone. So that's what we're always looking for. So for this one, I asked you slope is negative 2/3, the y-intercept is negative 5. This is telling you that m is negative 2/3 and that b is negative 5. You don't have to write that because it's given to you, but that's exactly what I'm saying. But I used words in this one, and we used words in this question, and you're going to fill it in. So in this case, there's nothing to find because you have everything, and you're just going to do your concluding. You don't have to put the therefore. I do it sometimes just because it feels like that's the right conclusion answer, but you don't have to put the therefore. So 3 little dots means therefore, right? So I think we've mentioned that before in another video. So it'll be negative 2/3, so you're putting in the m, and you're putting in the b. X, now what did I say about the x? I want the x, when you have a fraction here, to be written in the middle of the fraction. Not at the bottom of the fraction, that's wrong. You can put it closer to the top, that's okay, but I prefer the middle, never at the bottom though. That's actually a different thing, and we'll learn about that way over in grade 11, what happens when it's in the bottom. Okay, but it has to be kind of in the middle. And then here I asked you not to put plus minus 5, but just to put minus 5. So I asked you not to put plus negative 5. Right? I know it says plus b, but when it's a plus negative 5, we just simplify that to be negative 5, so minus 5 there. All right, and again, it's just because you can simplify further. So this is easier to read when you just simplify. So plus negative 5, I know it's plus, but we just put minus 5. Right, I've mentioned that before, so hopefully that's becoming more comfortable. So please don't, the things in the bubble are your brain thinking. You don't have to write that as part of your answer. Next one, the horizontal and the vertical lines are considered special cases. I do need you to know these because, again, we're going to use this forever and ever for horizontal and vertical lines. So 6.6 is still the equation of a line like we did in 6.1, but what we're doing here is just repeating and repeating so that you get comfortable. So horizontal line. Horizontal line goes through, going through this point. Whenever I have a horizontal line, until you get really comfortable with it, I picture it. So I go, this is my brain. Remember, bubbles are your brain. And I know this is x and y. If something is horizontal, it's going this way. This way. This is horizontal. Across is horizontal. If it's going through the point 0, 3, 0 for x, right, and y is 3, then it's going through 3 on your y-axis. So I picture y-axis, it went through 3, and it's doing this. So that means the y values are 3 forever. Y value, so the height of it is 3 forever. And that makes the equation y equal 3. So for any horizontal line, it's y equals the number. And for any vertical line, so picture it again. Picture this one again. A vertical line is, and I go like this, and I say, okay, this is my x and y, and it's going to, there's my x and there's my y. If it's a vertical line, it means it has to go up and down, so it has to be doing this. It's up and down, and it's going through the point 2, 0. 2 is my x value, and 0 is my y value, so 2, 0, so here, and it's going vertically, so it has to be doing this, which means my x value remains the same all the way through. X is going to be the same all the way through. So this gets me the equation x equals 2, whatever the x value is. So that's what a horizontal and vertical line look like. They are always going to be an x equals number for a vertical and a y equals number for a horizontal. Right? And those are special cases. So we're going to star this question. I'm going to say, okay, this is horizontal and a vertical line. Okay, and those are just special cases of the line. You can leave it written like that. So I know it says to write it in the form y equals mx plus b, y equals 3. This one here, there is no y equals mx plus b form because there is no y value. It's just x, so leave it like that is fine. Here we go. The next one here says it's passing through the point negative 2, 5 and negative 2, 0. So then I can go ahead and I can treat it like the other question before, and I can say, okay, if I have 2 points, my first step would be to find my slope. When I find my slope, I start with the equation. M equals, and look, I'm putting the equals, and I'm putting the line here, and I start with the lowercase m, and I start with my formula. Okay, so title, formula, make sure there's an m here, lowercase m. We're going to fill this in. When I fill it in, what do I mean by fill in? This is 0.1, this is 0.2, and I said it doesn't matter if you flip those 2 points. It's the same thing. It'll mathematically simplify to be the same numbers. So when I plug this in, substitute this in, see how I put the equals and I lined it up? That's how you can always make sure your questions lined up nicely. 9 minus, and it's a 5. x2 is negative 2 minus negative 2. So what do you notice here? These are the same numbers. So if you notice this from the beginning of the question, you could have done this a bit faster. You could have said, wait, but if the x's are always the same, then that is going to be one of my special cases. If x is always the same number, then it's this special case where it's going to be, so if you picture this, again, your brain, you go, wait, I can see that 2 of the values are the same. X is negative 2, 5, so it's going to be over here. Negative 2, 5, which is here. Negative 2, 9, which is above it. So this is 5, and this is negative 2, and this is 9. So that means it's going to go up and down like this, which is a vertical line. So if you see that, you can skip right to the equation. But if you didn't see it, what will happen is that, look, 9 minus 5 is 4, and then on the bottom I get negative 2 minus minus 2, which is 0. This is undefined. That is an undefined slope. So whenever you get a 0 on the bottom, it means it's an undefined slope. So you write undefined, you get this, and you go, oh, that's cool. So it's an undefined, which tells me that it's vertical. So it's a vertical line, so that tells you this. So in your brain you go, ah, so it's a vertical line. In your brain you go, oh, I know what that is. If it's a vertical line, it means it's going to be an x equals, and then you look and go, ah, look at that. 2 x's are the same. So therefore, my equation is x equals negative 2. Always negative 2. That's my answer. Right, so it's undefined slope, and I don't need to find b because the equation is always going to be x is negative 2. So there's no need to find b. So yes, this is another special case. So I'm going to star this one as well. Right, that is a little bit of a special case. Not a little bit. That is a special case. The vertical and horizontals are.